Hey guys, in these next two sections we're going to be looking at a couple of very well-behaved sequences that get special names because of their behavior, but the first of which we're going to look at here is what we call an arithmetic sequence. And so what I want you to see is that, for example, I've given these three sequences here, and really what I want to look at is just kind of their patterns. And so when you look at, say, sequence A, it looks like it goes from -2 to 1, 1 to 4, 4 to 7. If you ask me, this looks like it's just kind of progressing by adding 3 every time. And so I am going to make a little note here. I think that it's a good idea that you do put this +3 on here. But this would indicate that if I were to graph it, basically it would look like a linear situation. Now, B is a little bit different in that it is not adding on the same number every time, but it's subtracting off the same number every time. But it is a constant distance between each of these numbers here. And then looking at sequence C, it looks like 2 sevens, 3 sevens, 4 sevens, 5 sevens. You could interpret this as the numerator is going up by 1 every time, but we could also interpret this as between terms we're adding a 7th on to each previous term to get the next term in the pattern there. And so with all of these common changes from term to term, I'd say that all of these sequences have something in common, and that is that they are changing by the same amount every time. And so we're going to make sure that we put a note here. But we can say all of the sequences are adding or subtracting the same number to each consecutive term, or with each consecutive term. So essentially we can say that these sequences that do change by this constant amount every time with addition or subtraction are considered to be arithmetic sequences here. And so in terms of what the sixth term would be for each of these, you can see that it'd be really easy to predict what they would be as long as we know what this common change is between our numbers here. And so let's go ahead and define what we mean by an arithmetic sequence in the first place here. So we say arithmetic sequences. In an arithmetic sequence, the difference between consecutive terms is constant. So a few things here. Difference implies that we are using subtraction to find a value here. And then consecutive terms, what we mean by consecutive is back-to-back terms. So this is what we mean by consecutive. If two back-to-back terms have a consistent or a common difference between them, then we would say that by definition you're arithmetic. And so let's also define what we mean by common difference. The common difference, which we indicate with the letter D, is the constant difference between consecutive terms of an arithmetic sequence. So we call this the common difference. We use the letter D to denote it, and its definition is this, what you see right here. Now, in terms of formatting, this isn't very good formatting on my PowerPoint, but what it does say, or what it should say, is this. The common difference is equal to the value of the nth term minus the value of the n minus 1th term, or that is to say, to subtract the value of any term from the term that we're at. And that's still not a very good way to say it. We would just say that you take a term that you're at and you subtract off the term before it. That would be the difference between two terms. And so determining whether or not a sequence is arithmetic is as easy as looking at the terms and determining whether or not there is a common difference between them. And so some of these we can kind of eyeball. That is to say that from -5 to -3, it went up by 2. -3 to -1, it went up by 2. From -1 to 1, it goes up by 2. And from 1 to 3, it goes up by 2. But what I want you to see is if we were to grab any two terms, let's say the -3 here, and subtract off the term right before it, what we would get is -3 plus a +5, which is 2. And if we were to grab the -1 and subtract off the term right before it, the -3, we get 2. And if we were to grab the 1 and subtract off the -1 right before it, we would get 2. So the idea is the common difference is always what you get when you subtract one term. I guess subtract from a term the term before it. Okay. If there is a common difference, then it is arithmetic. And so because every term has a common difference here of 2, we're going to write that this one is arithmetic. Now letter B here, to determine whether or not it's arithmetic, maybe the pattern doesn't stick out to me here. Maybe I do take a moment to go ahead and say 8.5 minus 10. So what this means is from here to here, it went down by 1.5. Does it do it again? Well, if we grab 7 and we subtract off the term before it, 8.5, we get -1.5. If we grab 5.5 and subtract off the term before it, 7, we get -1.5. And if we grab 4 and subtract off the 5.5 before it, we get -1.5. And so this is also arithmetic. Okay. So with respect to these being arithmetic, we're looking for a common difference. Otherwise, we just want to state the common difference. For the first one here, it would be 2, and for the second one, it would be down by 1.5 every time. So now looking at sequence C, we have 1, 2, 4, 8, 6. 16, excuse me, if we do 2 minus 1, we get 1, but what you quickly notice is if you do 4 minus the term before it, we don't get 1. And if we do 8 minus the term before it, 4, we don't get 1. And so because these are not all a common difference, then we would say that this thing is not arithmetic. Okay. So with respect to this last sequence, if we did 1 minus 2/3, we would have the same thing as 3/3 minus 2/3, getting a common denominator as 1/3. So from 2/3 to 1, it goes up by 1/3. What if we did 4/3 minus 1? Take this term minus the term before it. Then we would get 4/3 minus 3/3, which is also 1/3. Checking out the rest of these, 5/3 minus 4/3 is 1/3. And 2, which is the same as 6/3 minus 5/3, is 1/3. And so this would be considered to be an arithmetic sequence. And we would say that the d value is simply put positive 1/3 here. So in this next video, we're going to take a look at how we can easily write the rule of an arithmetic sequence if we know the first term and the common difference. Cheers.